the hyperbola. It is the most eccentric of the conic sections, has a lot of different attributes that make each hyperbola unique. Now we have two types of hyperbolas. One hyperbola is the horizontal hyperbola. The horizontal hyperbola has branches that go through the x-axis. Now, the vertices aren't always on the x-axis, but it will always touch the x-axis at some point. Those two branches are horizontal in this case, and the equation for that one is x minus h squared over a squared minus y minus k squared over b squared equals 1. X is the positive term, and so that's what makes it horizontal. Now, the other type of hyperbola that we have is a vertical hyperbola, and this one goes through the y-axis. Not always nice and pretty on the vertices like that, but it will always go through the y-axis at some point. Now, this vertical hyperbola has a different equation. If you'll notice the difference between the equation for the vertical hyperbola and the horizontal hyperbola is that this time y is the positive term. Now, it's still y minus k squared, but you'll notice that the letters change as well. A squared, a squared. This is because size does not matter in hyperbolas. What matters is sign. So all the major stuff happens with x when you have a horizontal hyperbola, and all the major stuff happens with y when you have a vertical hyperbola. So I'm just going to mark up my graph a little bit. Now we have a few things that we need to recognize in a hyperbola. Those are the vertices, and the vertices are on the endpoint of the transverse axis. We use A to tell us where those things are. In our vertical hyperbola, it's the same thing. That's still the transverse axis, and we're still going to use A. Now, there is also some Co Vertices that don't actually appear on the graph, but they help us define the shape of the parabola, and those Co Vertices are at the endpoints of what we call the conjugate axis. You'll never actually see these, but like I said, they will help you create the graph. The number for those comes from B. Once we have those things in place, we can graph our hyperbola by looking at the relationship of these two axes. I like to draw a little rectangle, because this tells me where to draw my asymptotes. Asymptotes are something that are unique to hyperbolas. The asymptotes will go through the corner of these rectangles and the center of the hyperbola. So you can see why having those co-vertices are important. They're going to help us define those asymptotes. The last thing I'm going to mention before we move on to some sample problems is the eccentricity. The eccentricity comes from the foci and the major vertices, or the important vertices. The foci of a hyperbola happen outside the hyperbola. So I just sketched a couple of them in there. So it's farther to get from the center to the focus than it is to get from the center to the vertex. So our eccentricity of one of these hyperbolas is going to be C over A. C is still our focal distance, just like it was with the ellipses, over A. And in this case, it's going to be bigger than 1 because C will always be larger than A. To find the eccentricity, we use the formula that C squared equals A squared plus B squared, because this time we're looking for a bigger number. Now that was a lot of information all at once. Let's actually see an application of it so we can see where each little part plays in the graphing of a hyperbola. So this hyperbola, x squared over 16 minus y squared over 36 equals 1. I know it's a hyperbola because of that minus. And I know it's a horizontal hyperbola because x is the positive term. This tells me where all my major stuff is going to happen. Now the center of this one is just 0, 0 because you can't see an h and a k. That means it's 0, 0. So I'm going to go ahead and get this hyperbola started in a graph. I know that the center is at 0, 0. And the center is not actually on either of the branches, but it's important to help us define where those vertices are and where the co-vertices are. So looking at our equation, we have 16 under the x squared. That tells me that I need to move 4, because the square root of 16 is 4. And I need to move 4 in the horizontal direction. Right 4 and left 4. So that gives me my 2 vertices. So I can write the coordinates for these vertices. The vertices are going to be at 4 and negative 4, 0. So I'm going to write it as plus or minus. You don't have to use plus or minus. You can put them all together. Now our co-vertices, that's going to come from the number with the y in this case, and that means we're going to move up and down. So square root of 36 is 6, so I'm going to move up 6 from the center and down 6 from the center. So that gives me my co-vertices of 0 plus or minus 6. Now we have a lot of information already so that we could start to sketch our hyperbola. I can sketch out the rectangle created by these vertices and co-vertices, and therefore I can sketch my asymptotes. I know that it's horizontal, so I know that the branches are going to go through these vertices in the x direction. And all I'm missing now are my foci. So to find our foci, we have to use that equation, c squared equals a squared plus b squared. So in this case, c squared equals 16 plus 36. So c squared equals 52. So c equals the square root of 52. So to simplify that, remember you think about perfect squares that go into 52. So 52 I think is divisible by 4. That would be 2 root 13 because the 4 would come out and become a 2. So now we have C. This tells us how far we need to travel from the center to get to our foci. So it says go out 2 root 13 and go out 2 root 13 left from the center as well. So our foci, we can write them as plus or minus 2 times the square root of 13, 0. That way we don't have to write them both out. Now, the length of our transverse axis is the next thing we're going to look for, and that's the distance between the two vertices. We went 4 and 4, so the length of the transverse axis is 8. The eccentricity of this hyperbola is 2 root 13 over a, which was 4, which can simplify just to be the square root of 13 over 2, because we can simplify the 2 over 4. Now the trickiest part of hyperbolas is writing the equations of the asymptotes. The equations of the asymptotes are those two lines that we used with our rectangle. Since they're lines, I'm going to write it in point slope form, and in this case it's kind of easy because the center is 0, 0. But I'm going to write it out with point slope form anyway so you can see what it looks like. We have y equals plus or minus, that covers both lines in the same equation. The change in y over the change in x was 6 over 4, so 3/2 is the slope of the line, times x minus h plus k. So you can see why in this case, since the center is 0, 0, the equation of the asymptote is just a simple slope-intercept form equation. Y equals plus or minus is 3/2 x. You can see by looking at the graph that that's where those asymptotes lie. Alright, that was a lot of information. Let's look at one more so we can see what happens when our center is not 0, 0. So we can see that this hyperbola for sure has a center that's not 0, 0. The other thing I'm noting about this hyperbola is that y is the positive fraction. This tells me I'm going to have a vertical hyperbola. Let's start with the center though. Our center is HK, so look over with the x and you can see that the x is 0. And with the y, that will get us k, it's -2. So that gets us our center. I'm going to go ahead and get my graph started now while I'm thinking about it. 0, -2. There's my center. Now to find our vertices, we need to look for the number under the y. That's going to tell us where all the major stuff happens. In this case, it's 36. So this tells me I'm going to move up and down 6 from the center to get to my 2 vertices. So if we move up 6 from -2, we're going to end up at 4. If we move down 6 from -2, we're going to end up at -8. So my 2 vertices are 0, 4, and 0, -8. Before we can sketch our hyperbola, we need to also find the co-vertices. So the co-vertices are going to come from the number with the x, and they are going to move in the horizontal direction. So it looks like 64 is b squared, which means b is 8. So that means we're going to move left and right 8 from the center. So that gives us our co-vertices of -8, -2, and 8, 2. So now we have enough information to sketch that rectangle. Like I said, that'll help us draw our asymptotes. Foci. Let's find the foci next before I finish my graph. The foci are going to be found using the equation c squared equals a squared plus b squared. So in this case, c squared is going to equal 36 plus 64. So c squared equals 100, so c equals 10. I like it when this happens because it's a lot easier to visualize where these foci are. So we're starting at the center, remember, and we're moving up and down 10 because this is a vertical hyperbola. So if we move up 10 from -2, we're going to be at 8. So 0, 8 is one focus. If we move down 10 from -2, we're going to be at -12. So 0, -12 is the other focus. Now we can finish up our graph. I'm going to sketch in my asymptotes. And then I'm going to draw my 2 branches. Making sure to follow those asymptotes. They tell you how wide your branches are. We can answer a few other questions about this hyperbola as well. The length of the transverse axis is the distance from vertex to vertex. So if we went 6 on half, 6 on the other half, we went 12 all the way. The eccentricity comes from c over a. So we said that c was 10, and a in this case was 6. So this eccentricity simplifies to be 5 over 3. Bigger than 1, which is what we were expecting. Now for the equation of those asymptotes. This is the tricky part. Y equals. Now we need to find the slope. The slope is the change in y over the change in x. So that's why I like the rectangle. It's easy to see that my change in y and change in x are just a and b. In this case, the change in y is 6, and the change in x is 8. So our slope is 6 over 8, which simplifies to be 3 over 4. So in my equation, I know I have both a positive and a negative example of this line. X minus h squared plus k. And again, this is an example that actually could get simplified a little bit more. We could say y equals plus or minus 3/4 x, oops, that squared shouldn't be there, minus 2, because they're lines. Alright, so that was a shifted hyperbola. Let's look at one more graph before we move on to writing the equations for ourselves. This hyperbola has been shifted in both directions. We can see we have y plus 5 and we have x minus 1. So that means our center is going to not have any zeros in it, so this is sort of the trickiest type of problem. Since I was talking about the center, let's go ahead and fill that in. We're going to have a center of 1 and negative 5. And based on the positive fraction in this equation, we know that it is a vertical hyperbola. So that means our branches are going to be up and down. Our center of 1, negative 5, I'm going to go ahead and get that started. Now our co-vertices are going to come from the number under the y. So square root of 9 is 3. That tells me I'm going to move up and down 3 from the center to get my vertices. Well, if I'm at 1, negative 5 and I move up 3, then I'm at 1, negative 2. And if I'm at 1, negative 5 and I move down 3, I'm at 1, negative 8. Now for my co-vertices, those come from the number here, in this case with the x, so the negative fraction. So this is 1, and the square root of 1 is 1. So I'm going to move over 1 and over 1, and I have my co-vertices. So in this case, if I move left 1, I'm at 0, negative 5. And if I move right 1, I'm at 2, negative 5. So now let's find our foci using our equation c squared equals a squared plus b squared. So in this case, c squared equals 9 plus 1. C squared equals 10. So c equals the square root of 10. That means we are going to move, in this case, up or down the square root of 10 and get to our foci. So the square root of 10 is a little over 3. So we're going to move up a little over 3 and down a little over 3. So when we write out the points for our foci, we want to think about what we did. We started at negative 1, negative 5, or sorry, 1, negative 5, and we moved up and down the square root of 10. So the 1 stays the same no matter what. And we started at the square root of 5, and we moved up the square root of 10, and we moved down. So I'm going to write them all as plus or minus. You could write both of them out if you wanted to. Now we have enough information to actually sketch our graph. There's my rectangle, my 2 branches, and we can see how we can get those asymptotes from the rectangle that we have graphed. So I'm going to skip ahead to asymptotes. We're going to have y equals plus or minus the change in y, which was 3, over the change in x, which was 1. So the slope is just 3 over 1, or 3, times x minus h plus k. That's minus 5. I was looking at the wrong thing. So that's the equation for our asymptotes, and you can see that it's definitely in point-slope form. Now we want to find the length of our transverse axis and our eccentricity as well. So it looks like our transverse axis from vertex to vertex is 6. And our eccentricity is the square root of 10 over 3. So that was graphing hyperbolas. Now we're going to look at writing the equations from hyperbolas, from the attributes of hyperbolas. So we're sort of going backwards. So we have a hyperbola where we're given the vertices and we're given one of the foci. To sort of figure out what we have going on here, I'm going to sketch a graph. It'll help you visualize what this hyperbola looks like. Negative 2, 9 is one vertex, and negative 2, negative 7 is the other vertex. What does that tell you about the direction of this hyperbola? Because those are the vertices, it is a vertical hyperbola because they are up and down. They change up and down. They're along that same line. We actually know that line is the transverse axis. So this tells me that I know my equation is going to start with y. And if I know these two vertices, I can actually find something else out. What lies right in the middle of these two things? The center. So I know that my center is halfway in between these two. Now the whole transverse axis is 9 to negative 7, which is 16. So half of it is 8. So that means if I move down 8 or up 8, I'm going to end up at the center. So in this case, the center is going to be negative 2, 1. Now that I know my center and I know my direction of opening, I can get my equation started. Y minus k squared over something minus x minus h squared over something equals 1. We can actually find one of those somethings too. We know the distance from the center to the vertex. That's going to be 8. We just talked about it. And so 8 squared is 64, and we have the denominator of our first fraction. We found all of this information only using half of what we were given. So now let's look at what else we were given. We know that a focus is at negative 2, 10. So it's just up here. Well, that lets me know C, because I can figure out how far that focus is from the center at negative 2, 1. In this case, that's going to be 9. Before you get all excited and put that 81 into your equation, remember that that's C. So for hyperbolas, C squared equals A squared plus B squared. In this case, we know that 81 equals 64 plus B squared. So now this is just an equation that we can solve for B squared. We're going to have to subtract 64 from both sides. So we get 17 equals B squared. Before we worry too much about the square root of 17, remember, you need B squared in the equation. So we're good. I'm going to add my 17 to my equation, and we have the graphing form of the hyperbola with those particular attributes. Good job. Let's look at one more. So here we're given some foci, and we're given a co-vertex. We want to find the equation for this particular hyperbola. Well, to get started, I'm going to sketch a graph. I know my foci are 1, 2, and 11, 2. So I'm going to have a point at 1, 2, and 11, 2. Now, the foci happen along the transverse axis, where all the important stuff goes. So this gives us a clue as to the direction of our hyperbola. This is a horizontal hyperbola because the transverse axis is horizontal. We can also find something that lies smack dab in the middle of the two foci. The middle of the two foci is the center. So if from end to end here we travel 10, 1 to 11, halfway we would travel 5. So if we were at the point 1, 2, and we traveled to the right 5, we would then be at our center, which would be 6, 2. So now I have enough information to write my equation, or at least get it started. I know that I'm going to have x minus 2, 6 squared over something, minus y minus 2 squared over something equals 1. Now this 5 that we spent all that time finding actually represents C, the distance from the center to the focus. And that doesn't help us because in our equation we need A and B. So let's look at the other piece of information we are given. We're told that a co-vertex is at 6, negative 2. So 6, negative 2, I'm going to draw that there. Well, the distance between the center and the co-vertex gives us a clue to what our equation is. So if I were going to go from 6, negative 2 to the center of 6, 2, that is a distance of 4. Since it's a co-vertex, that number is going to go with the y in this case. So 4 squared is 16, and I have my b squared. Well, now we know c and we know b. We can go ahead and find a using that equation we have for the foci. C squared equals a squared plus b squared. So 25 equals a squared plus 16. Subtract 16 from both sides, so you get 9 equals a squared. So we could find the vertices and all that good stuff. However, we're just trying to write the equation, so we have enough information to write our equation. A squared goes in the bottom of the fraction in the denominator, and we have the graphing form for this particular hyperbola. So hyperbolas have a lot of different pieces to them, and really the best way to get really good at graphing and writing equations for hyperbolas is to practice it. That way you're familiar with all those crazy words and all the different formulas we use to find all those parts of hyperbolas.